Next speaker is Charles Young, DIY power for your equipment at a dark sky site. Charles.
Thank you, Tom. Hi, everyone. Hi, everyone. Good evening. Thank you for giving me an opportunity tonight to share my power solution journey. Before I start, do want to apologize that last month, because of some technical difficulty, I cannot share the solution, the story last time. And hopefully tonight we're going to have an amazing team in here. And if you haven't seen all the equipment and the intelligent people in here, so come next time and you'll be amazed with this team in here. And also, while I'm doing the presentations, I like interactive, so I'm not sure Tom will like that idea. So if you want to ask me questions, like asking me lots of questions will make me less nervous, and then I will be able to present better as well. Now, if I want to talk about my power solutions journey, I believe the story will start 40 years ago, and I have to figure out how to do the presentation right here. Okay, so 40 years ago, when I get my first telescope, as usual, it's a very long focal length telescope. So we'll have a fantastic view of the Saturn ring. And then someone eventually showed me an Orion nebula. And then I take a look at that. It's just so amazing. And so I decide to take out my camera attached to the telescope. And I want to take a photo. So I use a very steady hand, slowly turning the mount and track the nebula. And I did capture the nebula in the with a camera 40 years ago. Now, but I think that's very, very difficult. It is true. Even I get it, it's still very difficult. So I think there must be a better solution. So I go back and talk to the people that manufacture the telescope, and they do sell something what they call a synchronized motor. It's a 110 volt, 50 hertz motor, and the 50 hertz will synchronize with the rotation of the Earth. That's why all you need to do, plug the motor into the outlet. And then because the outlet is 60 hertz, it will turn the telescope according to the rotation of the Earth. However, the place where I got the telescope 40 years ago, they're running at 220 volts, and also it's a 50 hertz system. So that means I cannot just plug the motor into the outlet. So what do I need to do? I have to build a customized controller. So the customized controller, I'm designed to build a circuitry which transform a 12 volt power into a 110 volt and 60 hertz AC power. And then I also have a knob in the controller so that I can change the hertz of the output voltage so that it can make the telescope to go faster and slower. Now, what is the amazing state-of-the-art power solution 40 years ago? It is a 12 volt batteries. So it's a shielded lead acid batteries. The size is very small. So how small it is? If you do have a UPS system at home, the battery that used to power the UPS, that is the battery that I'm using. So let's fast forward to today's need for power solution. So there are so many needs to have a power solutions in place. For example, you want to observe the same object continuously. You want to use a go-to telescope in the stargazing, public stargazing event. You do want to take some astrophotography, and you need power to power all your equipment. And also, you may have a lot of other scientific research equipment that you want to power as well. And sometimes you do want to stay warm, and then using a power solutions can help you to stay warm as well. So with all this in mind, how about let's get started to build the solutions? But I would say not yet. So I would like to bring the people to think about one thing, which is before you build anything, buy versus build decisions. Because today, there are so many solutions out there you can actually buy. So what is the advantages of buying the solutions? It's immediately available. It's a proven solutions because they did a lot of testing and a lot of people are using it already. And also it's serviceability. If it breaks down, you can bring it back to where you buy and then you will get it fixed as well. What is the con? More expensive. I believe it's a perception that is more expensive. Is it really true? I let the people decide on that as well. Now, what about building your own solutions? And definitely the number one is a customized solutions that you can customize to any your own specific needs. And then you can select the best of the breed component to make the solutions work. And also you can make it cheaper as well. And I believe that is also another perception that we think we can make it cheaper as well. Now, what is the disadvantages of building the solutions? You have to run through a lot of testing. I'm pretty sure if you want to build a solution, the first time it may not work. And so you have to spend a lot of time and figure out what the problem is as well. And also is the reliability. Have you ever imagined that you go out in the dark sky, bring your solutions together, but it didn't work? So building a solution, sometimes you will have these disadvantages as well. Now, what's available for us to buy today? First thing that come to my mind, solutions power tank, and that's the first one that I got introduced to power specifically for telescope and the mount as well. So you can see it on the picture in the top row. That's the Celestron Power 17. Inside the solution is a lead acid battery. It's a 12-volt lead acid battery. And then with that solution, you can see all the other different products out there that you can buy as well. One thing to capture my eye in the first row on the last one, the yellow solutions that you see on the screen, there is a solutions that you have a power drill or a power saw, a cordless power drill saw. You have a batteries. And now you can actually buy a device, an inverter, plug it into the batteries, and then you turn it into a 110-volt solution, and you can start to use it as well. So it's just amazing of like how easy to turn any existing solutions into something that we need. Now, and then in the newer category, which we all talk about right now, nowadays, is the lithium solutions. So most of the solution is building off a 12-volt batteries with the lithium, either lithium iron battery inside or a 12-volt lithium iron phosphate power solution as well. There's so many brands, to name a few, Jackery, ECO Flow, Blue Eddy, those are all very good brands. And there are also other solutions that you can buy from Amazon, which is a non-named brand. Is it going to work? I would say yes, it's still going to work. Am I using it? Yes, I am using one of them as well. But it is cheaper, but sometimes, for example, if my solutions break down right now, I could not find the supplier who can give me service of the power stations that I bought from them earlier. Now, if we want to build it, let's take a look at what the other people is doing as well. So this year I went to the Starfest and then talked to different people and then take a picture of what the other people is doing with their solutions. What you can see on the screen, people using boxes and put the batteries inside and then lots of wire and then trying to run all the different kinds of outlets and power the solutions. And then on the right side, you can see people is using a I believe is a solar panel solution as well. Use the solar panel, charge up the batteries, and then use the batteries to power all your equipment. Now let's talk about what are the steps that we need to build the power stations. In general, it could be more than this 7 steps, or it could be less. But in my view, like when I doing my solution, these are the steps that I follow. Step number 1, gather the requirements. And then step number 2, based on the requirement, design your solutions. Decide what you need. And then once you know what your design is going to like, the step 3 is to go out and get all the components. Either you buy it or you salvage from your existing equipment or anywhere you can actually get those components from. And then once you get all the components in place, you can start the constructions. And then once you finish the construction, then the first thing is turn it on. Let's see if you can actually get it to work. If not, then you have to do a lot of testing. Once you finish the testing, you may have to go back and modify your solutions because when you look at it, it just may not exactly fitting what you need. You will continue to improve your prototype until you are satisfied with what you are building as well. And then the last step, everything is now working, everything is perfect. You bring it out to the field and doing the first field test. So I would say when you're doing the first few tests, make sure you have a backup solution as well, because it may not work the first time in the field as well. Any questions from the audience here? If not, let's carry on and see what are yes, there's a solution. Questions?
So we have a question from the chat, from Zapfan, who just asked, how many watt hours are needed for a night running a telescope?
Okay, how many watt hour I need for one night of operation? In my experience, I operate a reasonable size mount, CGX, which can power 40 pounds of equipment, running a laptop, which is a laptop that consumes about 45 watt. And I do run some camera as well, so I need batteries to power the camera. I just don't have any dual solutions to remove the dual, which takes a lot of power as well. So for that equipment, I am running 300 watt hour battery solutions, and then it's sufficient to run through the whole night, starting from say 8 p.m. until 1 p.m. or 1 a.m. or 2 a.m. Okay, so any other question before we flip on and look at details of what the steps are? So number one, step one, gather your requirement. So you need to know your own requirement so that you can make the right design decisions. So as the question earlier said, how many equipment do you need to power? What is the duration of your operation? Like how long do you want to stay? And also what the environment is going to look like when you're running your solutions. For example, do you have AC right there available for you to plug in? And then after that, you have to think about how to recharge your power station. Your recharge solution kind of like could be complex as well. And then at the end, do you want a all-in-one solutions or you want a multi-component solutions as well? So to run through a couple of my requirements when I build my solutions, because all these design decisions do make some implications at the end when you put the solutions together. So my requirement is I don't want all the different components laying around and then bring it to the field and then constructing and connecting it all and trying to expecting it to work. But I cannot afford to have an all-in-one solution as well. So I'm decided to say I want to have a hybrid all-in-one solutions, which is majority in one box, and some of them, some of the bigger component could be outside the one solutions as well. I want it compact, I want it lightweight, and I want it extremely portable as well. I want to maximize my battery's efficiencies, and I want to minimize the power loss as well. And I want to be able to sustain multiple nights of operation, because when I go to camping, I may not have access to electricity to recharge my batteries as well. And also I want it to be easily rechargeable. And one very important thing is I want it serviceable. I don't want to put the solutions together and then when it fell, I have to throw the whole thing again away and then build the solutions again. And then the last requirement for me is very, very important, which is expandable. What does it mean? Is to put the solutions together, but it will be able to accommodate in the future when you have a future need and future change in the requirement. And then you can continue to expand on your solutions as well. So how am I going to do that? Let's take a look at that. Now let's take a look at what the typical decisions you need to design. We do talk about a battery solutions. So batteries do come in different standard operating voltages. So usually we deal with 6-volt batteries or 12-volt batteries. But nowadays we can talk about a 24-volt, 36-volt, or 48-volt battery as well. Can I operate a 12-volt operated telescope with a 24-volt battery system? Yes, you can do that. There are components out there which can like bring down the voltage from a 24, 36 volt, or 48 volt down to a 12 volts that you need to operate your equipment. And then you need to decide on what is the battery type that you want your solutions to look like. Do you want lead acid? Do you want lithium iron? Or the latest technology, lithium iron phosphate? You want to decide how many batteries capacity do you need. When we talk about capacity, it talk about how many AH that you need or watt hour that you need. You want to think about, do you want just a DC solution or you want a DC and AC in both solutions as well? You want to think about what type of output that you need. Do you need a 110 volt output that you can plug in an electrical equipment? Do you want a cigarette car connector so that you can easily plug in a car cigarette connector to it? And also you want to think about what kind of input do you need for charging your solutions as well. So at the end, all these kind of decisions will drive what is the battery size, what is the current limit, the aperture limit, and also what is the wire size that you need as well. Now, there's always a misconceptions when we talk about power consumptions and how much of the power I need when I put in a power adapter. For example, people talk about I have a big telescope which drive 50 pounds of equipment compared to a telescope which drive 5 pounds of equipment. The 50 pounds usually it must be taking more power because the power adapter come with that could be like 50 watt or 100 watt power adapter. And so I did a test using my battery solutions, which can show me how much power wattage is consuming. So when the telescope is steady, just the auto tracking, 3.2 watt. And then when I start to turn and move the telescope to point to a particular position in the sky, so the two motors start to kick in, which will increase from 45 volt to 10.5 watt. And when it starts to slow down, that one of the motor is like ready, or is already pointing to the right part of the sky, and only the other part of the motor is driving, continues to driving, it get down to 8.5 watt. Everything settled, computer kicks in, 69.3 watt. And then at the end, when everything settled, I'm back to 3.5 watt. So I am using a 50 watt power adapter to just consuming 3.5 watt as well. Now, we talk about making the design decisions. So selecting the wire size is important. And also, I would say it's very dangerous if you're using the wrong size of the wire for the solutions as well. And because the wire size it drives the high current requirement, which is used to drive your equipment, and a very small, like when we look at the wire size, we talk about the gate size, which is like it could be from 0 gate to 22, 28, even 28. The smaller the number, the bigger of the wire. It's like the magnitude of the star as well, the reverse. So in a typical cases, if you want to drive 10 amps of current, you want a minimum of 10 gauge wire or 10 amp. I actually don't have a 16 gauge of wire as well. Now, and when the wire is depending on the current that is driving through the wire, a higher voltage with the same number of wire will drive the number of voltage is going to be coming out. So that means if you're using the same wire, but then if you're using a higher voltage, it will deliver a higher voltage, wattage as well. And you can see on the middle of the screen in the bottom, those are the chart that describe what is the wire size related to the current requirement that you need for your wire as well. And there's one solution, one options as well, which is because of the price of the wire of the copper is high right now, the wire is actually expensive as well. So if you do have access to some like smaller size of the wire, you can put multiple of them together, and then it will give you a higher current. It will be able to handle a higher number of currents as well. As you can see in the middle of the top, I put in the number of putting 6 18 gauge wire, it will turn it into an effective 10 gauge wire, which it can handle 30 amp of amplitude instead of like less than 10 amp. Now we have the wire in place. We have to think about what kind of connector do you need. As a very typical solutions, a lot of people is using this car cigarette adapter, but there are different kind of car cigarette adapter you can actually buy from the internet as well. There are adapters that come with wire, which is you see on the left side of the screen. But I decided that I'm not using that because the wire is basically really thin, which will not be able to deliver the currents that I am looking for, which I need to power, say 300 watt of 110 volt of my AC inverter. So I decide to buy the cigarette adapter without the wire. And then in the middle of the screen, you can see that I will go out and get the clamp connector to clamp the right size of the wire and connect to the adapter. When you're buying all this clamp adapter, you may also have to consider the different color as well, because different color means different size of the wire you can get into the clamp connector itself as well. In the nowadays, we also talk about not only driving the mount, we also have to drive the dual control or the dual controller as well, which you typically is using something you see in the middle on the bottom of the a power plug jack, which is the 5.5 millimeter power jack that you can connect a very small power connector to it and power a dual equipment. Now, why a lot of people also using the car cigarette adapter as well? As you can see on the right side, you need to drive some USB equipment, either USB-C or USB-A. You can actually get a cigarette adapter just plugging into the connector, and then you have a USB power as well. Now we talk about the 110 volt AC that you want to use. With accessing to the 110 AC volt, you basically have access to almost any equipment that you want to drive out in the field. For example, your laptop, your monitor, your telescope mount, the DSLR camera, also like some camping gear as well. The one I'm using is the one on the right side. I select the 300 watt pure sine wave AC adapter. Pure sine wave kind of is a better solution because when you look at your AC outlet at home, those are a sideways curve. And some of the equipment is designed to operate that with the pure sideways curve only. So for the cheaper solutions, non-pure sine wave, sometimes the equipment may not work as well. Now, next thing is getting all the components. One of the major components is the batteries. Where can I buy some batteries? You can go out and buy it. Or think about your old car batteries. So I did talk to the people, they're using an old car batteries and operate for 10 years and it's still working. And also like, nowadays you may have some unused UPS. So open up the UPS, you will have some lead acid battery inside as well. When we talk about the lithium ion batteries, where can I get them? You can go out and buy them, or you can open up the unused laptop. The battery, a lot of them is coming, is using the lithium ion battery solutions. Also, like think about getting some used hoverboard, e-scooter or e-bike, because those are the ones that can actually nowadays have the lithium ion battery inside as well. As you can see, there are some very cheap solutions of hoverboard you can actually get off and you can salvage the battery as well. Now, if anyone is using a EV batteries to power your solution, please feel free, raise up your hand, share your experience, post something on the internet and share what you have. And now we get down to the final step, which is like let's constructing all the housing and all the ports that you need. So I'm using a 3D printer to print all the solutions. And I go to the website and then there's a free website. We can actually go in and put in all your 3D design. And once you put in the 3D design, download the printable object, put it into your computer and you can start printing the components. Now, if you see the left panel and the right panel, you see the 12-volt batteries for the left panel, the 12-volt car battery adapter, and also the right side is for the inverter. And also you see the small square. This is where you can actually do an expandable solutions, which I decided to have a LED extension plugging into all the square box as well. Putting it all together, this is what my solution is going to look like. Now, once you have the solutions, you have to think about how to charge your solutions. For the lead acid batteries, the charging state is a 3-stage charging. In terms of time, I'm going to not going to look at all these like different stages. Lithium-ion battery do have a different charging requirement as well, which is a 4-stage. So when you're buying a charger, you can have a plug into the AC outlet and charge your batteries, which is what I have on the right side. Then you can charge either the lead acid or lithium-ion batteries. Or you can use a solar panel to charge your solutions as well. If you are using the solar panel output is typically around 12 volt to 50 plus volt. You need the solutions to bring the output of the solar panel down to the voltage that is required by your batteries. There are multiple solutions, PWM or MPPM, and I'm going to like go a little bit faster. That I'm not going to go into more detail. But if you do want to know about these solutions, if you have questions, feel free to let me know, post it on to the forum, and I can try to answer the questions as well. Now, everything now in place. There are a couple tips you want to share with the people that you want to avoid when you're putting your solutions together. Number one, don't short the battery's terminal because that will create fire. And number two, don't undersize the battery capacity. Think about that when you bring a battery solution, you think it's going to work. 3 o'clock in the morning, the battery die, and then you have nothing to power your equipment. And don't undersize the component and the wire gauge size. As I mentioned earlier, the wire gauge is very important. Make sure you use the right wire size for your solutions. Don't overdrain your batteries because sometimes it will kill the battery that you cannot bring it back to life as well. Don't expose the batteries into high heat. It may get fire as well. And don't use the 12-volt battery from your car to power your equipment. Because if you do that, it works great in the first half of the night, but then the next morning, you may have a problem to start your car again. And one thing that some people may not think about is like, don't expose your battery to extreme cold weather. That's why sometimes we still prefer the lead acid battery over the lithium ion because the lead acid, they can actually sustain a much colder environment instead of the lithium ion batteries. And the last one that I want to share is don't underestimate the dark sky and the dangers because you cannot see any color. Think about that, you reverse the plus and minus polarity and connect your equipment. It will blow up everything. So almost the end of my story. So to finish it up, I want to continue my journey. So recently some member, they do acquire a batteries, which is a lithium iron phosphate batteries. And the person just cannot charge the battery. So he just don't know what's the best way to do. And so he decided to give it to me. And then I take a look at that. The size of the batteries is actually the same size as I have 40 years ago to power my original equipment, which is the state-of-the-art power solutions. So I decided to turn it into another experiment or prototype. And this is what I get. So 3D printer, 12-volt car cigarette battery connector. It just looks kind of funny to me right now. So this is what I mean. You will have to continue to improve your prototype to make it better and suit your need as well. And that's my presentations. Thank you, everyone. Any questions?
Questions for Charles? Oh.
Thanks, Charles. That's an excellent presentation. I have a comment to add to your things not to do to batteries. And as you mentioned, the lithium iron phosphate are very sensitive to low temperatures. My experience with them, and I believe it's true, that you cannot charge them when they are below 0 degrees Celsius. They can discharge, they operate fine, but you can't charge them when they get that low. So that's something to keep in mind if you're going to be using this out in the field and look to charge it up with a solar cell in the daytime. The battery has to be warmed. Can't do that. And I agree 100% what you say about using red lights in the field. It's very difficult to see which is the red and the black terminals. So that's a good tip. Thanks very much.
Okay, thanks, Tony.